So this is a video I'm really passionate about. I got my start in security because of GitHub. I was a software developer. GitHub was my proving ground. I showed that I could learn concepts, I could build tools around them. And this is the guide I would have wanted when I was getting started with GitHub, just understanding how the security community uses it, and in general, understanding Git and general functionality. Whether you can code or whether you can't, I'm going to try and raise examples here of how you can provide value to the community. And it's October, so you can go and earn swag in Hacktoberfest. However, I do encourage you to try and make sure you're adding value on those repositories. There's a lot of spam in Hacktoberfest, and it puts a lot of hassle on maintainers. So make sure that you take the examples here and you try and contribute to them in some way with the pull requests that you use to earn that swag. But enjoy, and any questions at all, feel free to tag me on Twitter. I would love to help more people get into GitHub. It's something I'm really passionate about, and I'm excited to share it. Okay, so one of my favorite websites, GitHub. Basically, if I had to explain it to someone who wasn't familiar with it, I'd say it's a social media network for code, and that's probably going to make some people cringe, but it's kind of what it is. It's a website where open source projects can host their projects for others to contribute to follow, and to also clone and put on their local computer. It is built on top of the version management control system, Git. And I'm not going to get too far into the what is Git outside of how to use GitHub and explaining commits and pull requests and clones to you in this guide, but I'm going to try and put more of that in the written guide. I'm going to try and expand on that over time so that there's a better foundational knowledge there if you'd like to dig into it. But for all intents, this video is going to show you how you can get started with GitHub, build your own profile, and even if you can't code, how do you contribute to security-oriented projects. So this is a profile. This is my profile specifically. You can see contributions I've made, different activity that I've performed, and then projects that I've started up here. So if we go into Interlace as a project, you can then see all of the files associated with that and the latest changes that were made to them. These are coming from commits, which we'll dig into later. You can also see there's pull requests here. And if I go into a pull request, I can see code that someone else has contributed to this project. I can click into the commit and see what changes they've made, and so I can review that and say, look, I like this, I approve it, and I did review this earlier, approve it, and then these are test cases which you add on top of it. In this case, I know that I'm not too concerned about the test case, and if I wanted to, I could approve this as it is. I'm going to do that separately post this. But essentially what's happening here is that I'm maintaining a project in the public sphere. So I have Interlace. I work on this with Prodigy SML. We founded it together, and we can both maintain this project independently. He can write code and I can write code, and we can both push it up to this project without stepping on each other's toes, as well as allow anyone else contribute to this project if they'd like to. So they can create their own changes, features, and improvements, which is exactly what this person's done. They've identified something that we weren't doing very well. They've found a better way to do it, and they're contributing it back. So once they've done that, if we go to their profile, it's going to show the work that they've done on Interlace here. So it's a really useful way of expressing yourself through code online, but also finding useful projects, and, you know, realistically, cutting edge techniques often live here before they live anywhere else. So I'm really excited to show you GitHub and show you how to make the most out of it. So I'm going to use Keyhacks as a quick example of how you would contribute in just the GitHub interface itself. I do encourage you to dig further into this video to see how to do things on the command line, because that's really where a lot of the power of GitHub comes in, but this is a good starting point. So Keyhacks is a repository that contains a number of API keys and how to safely test for them. It's community driven, so if you go through a bug bounty program or your pen test engagement, you find a new key type and a safe way to reproduce it, it's great if you contribute it back. It's all powered on the readme.md file. And so how readme files work on GitHub, if there's a readme.md file in the repository, that will automatically display in rendered markdown when the project loads. So you'll see there's an edit icon up here. If I click that, then I'm going to see the raw markdown file. And so if I wanted to contribute a change here, I could put in some markdown. And so this jumps to a link, and then I'll say test, right? And I'll just say Laravel something here. if I go down to here, this is where I put in a description of my commit. You should never leave the defaults. It's very difficult for the author of the project to understand the change. They can very easily look into it and see what it is, but over time, the commit history gets jarbled with update readme.md over and over. So we would say add test. And these should be short, succinct, and explain the point. So it could be add test, or modified the Facebook app secret to have more information, things like that. You choose which email you're going to contribute to. Now, as a word of warning, I very, very much encourage you to use an email you don't care about with GitHub. They're public, they're stored in the open, and you probably don't want to receive the downside of that. And I'll tell that story one day. And after that, you should say, create a new branch for this commit. You probably can't see the commit directly to the master branch. I'm a maintainer of this repository, so I can. You'll see this on your own projects, but basically, master or main branch, I believe GitHub are migrating to calling these main. The main branch of a project is the central point where all changes are pushed into. So I'm going to make a new pull request here, and then I'll dig into that more. I'm going to say add test. So just like commits explain things, pull requests should as well. So the commit is the change that I've made on this file. I'm committing a change to this file. And then the pull request is saying, the creating of a new branch here is saying, I'm going to create a new branch off the main branch where this change is stored. So it'll just be in that branch, and then I'm going to propose the change, which makes a pull request. And a pull request is saying, this branch, Kadingo add test, has changes in it that would benefit the main branch, and I believe you should pull this into the main branch to be part of the broader project. And then testing for a video, please ignore. And so then when I create the pull request, that comes into the project maintainer's viewpoint. So because I'm a maintainer on this project, I'll see some options here you won't see. If you were a regular user who, and I'd say regular in the sense that you weren't a maintainer on this project and you contributed a change here, then you would just see the proposed pull request. And the maintainer comes in and they go, okay, I'm going to merge this change. Okay, so brand new username. We're not going to cover registration because that's pretty intuitive and I don't think that's going to be a worthwhile time to cover here. However, once you've logged in for the first time, you'll see start a project. So let's click that. We're going to make a project that we're going to use for the duration of this video. So we'll say video, right? And you can use very explicit naming because when GitHub generates its URLs to a project, it uses the username and then the repository name. So calling our repository even A, we can do that without worrying about conflicting with other users. There's descriptions, which allow people to find your project on GitHub, and then public and private. Private, you can invite others and you can contribute without it being available to the broader community. Public, anyone can contribute. We're going to make this private because I want to show you how some of the authentication mechanisms in GitHub work in later stages of this video. A README is recommended. That's that file that you see when you first land a repository we covered earlier. Likewise, I recommend a Git Ignore. Git Ignore says, essentially, these file types or these files, when I commit to my repository, don't push them up. So then for Git Ignore, you should choose the language that you're working in. So let's just say, look, this is a Python project. It'll also then create a default template for you that'll add things like PYC files, that your local cache files that you don't want up in your repository. So really, really useful to get a prefabricated file to work from. And license. And I tend to use the GNU license. It's a friendly license for others to contribute to and use projects that I've delivered, but I recommend if you really want to get into this, you should dig into those a little bit further. After that, we create the repository, and we can now go and contribute to it as we need to. So, starting back at our profile, you'll see we've got no repositories that we've pinned here yet, but we do have the one that we've created. So if we go into it, we can contribute to it. We can do that in GitHub if we want to. So if you want to make a folder, you need to make a file under it. So we can say, let's make the test folder. We'll just put a test file in there. And then we can commit the file. If we go back to the main directory, you'll see there's now a folder there and various elements to that. But this is kind of an inefficient way to edit. Doing everything in the browser doesn't really work very well. So how about if we take this a step further and we start to do it in the terminal? And to do that, first we have to clone the repository. So, confession time. I've intentionally made this a little bit harder. If you're cloning a public repository, you don't need to do any sort of authentication. Things are a lot simpler, but I want to show you how to work with private repositories because it's also going to make it easier to work with other people's projects. So I'm going to take you through a few extra hurdles, and if you've cloned a repository before, this might seem like it's convoluting the process, but it's really not. It's actually showing you some best practice in the process. So to clone, normally we would go here, we would say copy this and go to our terminal, we'd go git clone, done. And we could do that over HTTPS or SSH. The challenge that we're going to hit in a second is that this is a private repository and the terminal is not authenticated for it. So we're going to need a personal access token. So let's go through that. So my deception aside, let's create a personal access token. Firstly, we go to settings, we then go to developer settings, and you'll see under here, personal access tokens. There isn't one by default, so we have to generate one. So we go generate new token, we re-authenticate, and we'll just say token for cloning. And you'll see that these tokens can be classified with different permission levels. And if you do choose to use these, I don't think these are very good practice. They're useful in test cases, some other places, but you're better off using SSH on the whole, and we'll get into that next. But if you do choose to use these, you really want to be careful with what you give them. But to YOLO it, let's give it everything for this sake, just to create an example, and bearing in mind this is a throwaway user. I also don't want to dig into this because I don't want to get into giving permission level specific advice. I want to encourage you to read this yourself. So if you want to work out how to just isolate this to what you need it for, please dig into the documentation. But also please bear in mind, there's much better ways than personal access tokens. SSH keys really are the best approach. Once we have a personal access token, we can come back to our terminal. We provide our username and we provide the personal access token. And that essentially then authenticates, and what cloning is, it's created a local copy of our repository. You can see it here. So we can go into that directory and we can see the test folder that we made, and we can go under that. We can go under that and we can see the test markdown file we made. So we could now make changes locally and do what we want and then push it back up to GitHub. And all of that's being covered later in the guide. Before we do that, I want to touch on the better way I feel to authenticate with GitHub being SSH. Okay, we're going to create a new SSH key pair. There's a command here that's going to do just that for us. It's called SSH Keygen. It'll be available in any Linux distribution that you've got. The one thing you're going to want to change, this is the email associated with it. And if you care about that commit graph on GitHub, make sure this matches an email address associated with your account. Also, you would have seen the warning earlier in this video, any email address you use with Git is going to be exposed in some fashion, so be cautious of that. So we're going to do this. It's going to ask us where we want to save it. Do we want to save this direct? In this case we do. If you're moving SSH keys between different systems, you might want to specify a file name here. Otherwise, if you're unsure what this means, leave it as the defaults. And we'll say yes, we'll override it. A passphrase is good if you're using any sort of shared infrastructure. So if you're going to be on a VPS, you've got some friends use it with you, you would want to do this. But if you're not, let's go no and no. And we've now got our SSH keys, and they're saved, in this case, within the ssh.dot folder. Okay, so now that we've done this, we need to add the key to the SSH agent. This isn't done automatically. So assuming you use the same file I did, the default, this is the path you would use. Otherwise, you should path this to the file that you have. And we do that. So this has now put the private key within our SSH agent. That's the one that we're going to use to authenticate with the public key that we're going to put into GitHub. So to do that, let's copy it to the clipboard. So you can just pass the file into clip and it'll clip it for you, or if you're unsure what to do because you're working a VM, you can always use Jedit to open it and copy it this way. In either case, you need to get it on the clipboard, so then we can put it onto GitHub. And so now back in GitHub, we paste our public key, and we should describe it. So we should say videos VM for this one, for my specific description, so I know what that key is associated with. But you can really call this whatever you'd like, and essentially make sure it's a name that allows you to track machines. If you have multiple SSH keys over multiple VPSs, be descriptive, because it's going to allow you to manage and maintain these better over time. Once you've done that, go add SSH key, re-authenticate, and that'll be it. It'll then have added the key. See, you remember I was saying maintaining these, you'll see multiple keys here as you add multiple, when they were added and when they were last used via the description. So that'll be a really useful thing for you to track and maintain these. And I would also recommend trying not to reuse these SSH keys with other activities. If you're working a VM, you can just put those direct into the default pathing, but try and manage your keys appropriately so that if you do have a compromised key, you're not also seeing a compromised GitHub. So now we have SSH keys, we want to be able to clone using SSH. That'll allow any changes we make to be sent back up over SSH, so we don't need a personal access token, anything like that. So if we go back to code, you'll see here this is over HTTPS. We want to click this to be SSH and copy this to the keyboard. Assuming you've set up your SSH key correctly, you can use this with clone. So let's do that now. Now once we're back here, we just go git clone, and we paste what we copied before. It's going to clone the repository. So it's going to take the main branch and all the other associated branches in the repository, and it's going to sync it to our local computer. And once we have that, we can go into the directory. You can see our test directory that we made earlier and our testmd file. So now we're completely set up. We can start to make changes directly in the repository. And because we cloned it with Git, anytime we commit back, it's going to use Git and it's going to use our SSH private key to authenticate. Awesome. So we've covered a bit, we've done some stuff in the browser, let's learn how to do it on the terminal as well. So you remember before, we created this test directory and we put a file in it. We never actually put any contents on that file, so let's do that here, and assuming that we want to do everything in the terminal. So we're going to say test, we say this is a test, and we're going to write it. Now, once we've done that, we go back to our repository, we need to both add the changes and commit the changes. So if we go git add dot, it's going to add the changes, and git commit, and we need to give a commit message. So let's just say added contents to test. So we're trying to add, succinct, short, but clear messages. Once we've committed them, these now exist in our local Git, but we need to get those up to GitHub. So to do that, we use git push. And what push is saying is, take the changes I've got here and push them back up to GitHub. And if you're working on the main branch, that's going to push to the main branch. If we were working on a different branch, it would push it there, and then we would do a pull request to get that to main. So we'll do that in the following instructions, but for now, you'll see if we go back over to GitHub, you'll see at the core of the repository, our commit message shows here, because the latest version of commit, if we click it, you'll see it added this is a test. So if we go into test and then into testmd, we'll see this is a test. So it's now made that change to the website version of GitHub where the code is reflecting, because we did a git push to push it upwards. Let's break down what we just did a little bit more. When we did the git add, we're basically adding changes to be committed. And when we did our commit, that was saying we're going to commit everything that's been added to date. You could then do git add again to add a fresh round of changes. And this allows you to do some logical grouping. So if we had multiple files that were being changed for a single purpose, say we had a bug and we had to change it into locations, we would change both of those locations, add the changes, and then make a single commit describing that change. as opposed to committing on every single file change, which would make a very messy pull request. So let us do that in an example. Let's go into our test again, and we'll go and add to this file. So we will say in test.md, we're going to add a 2. And then we'll say vim test2.md, this is test2. So let's assume that this was code, and let's assume that both of these related to the same bug fix. We would then add both changes. We would commit this saying bug fix 2. So that's now saying there's 2 files changed with 3 insertions, and we can now push the change up. In this single commit, there are 2 separate changes. If we did that in 2 separate commits for the author that we were contributing to, or for someone coming to the repository later, they would have to look through multiple commits to understand the intention of the work that we'd performed. So grouping your commits makes a lot of sense, and you should try to do that where possible, but you should also try and have enough separation that it's not daunting looking at a commit. You shouldn't have 50 files that are changed in a single commit if it's not going to make sense for someone to quickly interpret the change. We haven't quite covered branches yet, so let's dig into that. You'll see if we go git branch and then -a, this allows us to list all of the branches in the project. That includes the ones that we cloned down, as well as any local ones. Notably, we haven't created any yet. In order to work on a new branch, we have to check it out. So we can check out an existing branch, or we can say git checkout -b, and this will make a new branch if it doesn't exist. They should always start with your username, and so we'll say Kidingo test2. This has now taken a copy of the main branch that we worked in before and called it Kidingo test2. Now that's a copy of that branch at a point in time. If we swap back to the main branch and we do a git pull to pull the most recent changes into our project, that doesn't update our branch. So this is where you could end up with merges and conflicts. If you take too long to make your changes and push it back up, other changes happen in the meantime, you're going to have a conflict that needs to be resolved before the pull request can be successful. So let's make some changes just in this branch, and then we'll pull it over to the main project. So if we go vim test3.md, we can go create, we can go to insert mode and go create test3. Now that then needs to be added, so we can then commit it. So we're going to go git add, and we're going to commit this. We're going to say created test3. We can then push this. Now you'll get this error here. What this is saying is that test2 exists locally. It doesn't exist in the upstream repository. So if we take this command and we run it, it's going to push this, but it's going to set the upstream origin to be a branch called Kidingo test2. So it's going to recreate this branch in GitHub and then push our changes up. You'll also note that it's saying that it's now set up to track remote branch test2. So it's essentially saying that future changes that we put here and we push, they're going to automatically push up to the test2 branch on GitHub. So if we were to rename this branch locally, that's not going to rename it remotely. So we need to keep that in mind. Additionally, if we come back to GitHub now, you'll see this, compare and pull requests. So we're in the main branch, but because we updated another branch, it's letting us know there was recent pushes there by our user. Do we want to pull request it in? So we can say compare and pull request, and it's automatically creating a pull request of our test2 branch to the main branch. So we can say testing 1, 2, 3, and we can create that pull request. And when we now merge that, that's now made that change in the main branch. And we can delete the branch safely because we're no longer using it. But if we were still using it remotely, then we shouldn't do that. We're going to have to then recreate the upstream origin each time we push. If we go back to the video repository, you'll now see in the main branch that we're within, test3.md exists, and it's got our contents within it. So putting all of this together, what are some good repositories you can commit to as an information security professional that wants to give back to community? So I have this GitHub organization called InfoSec Community, and I invite a whole range of people who help me run different repositories here. And if you have a repository idea, tap me on the shoulder. I'd love to add it and make you the owner of it. But these repositories at the moment are largely around the APAC region. So they contain things like all of the conferences that typically pre-COVID and hopefully post-COVID were running, what month they were running, location, and where. And this is all in Markdown, so you can either go through the first process we did and contribute on GitHub, or you can go through the terminal and contribute. The Disclose.io project also has a number of issues, another number of repositories you can contribute to. So the disclosure list is a list of different programs and different items that exist out there that you can report bug bounties to, and different elements. This one's in JSON, so you can either contribute in GitHub, expand the JSON and make sure it's going to pass the test cases, or you can do that in the terminal as we covered and push it up. There's also the Can I Take Over repository. And I'm going to do a separate video about this one at some point because I think there's a little bit of misconception about how this runs. There's this table on the front page, but the real power of this repository is in the issues. And it's great if you contribute to the main repository, but it's not going to be the most accurate information if that's all you interpret. But we'll cover that later. We also covered Keyhacks. This is that really useful repository we had in the beginning. And there's instructional content at the beginning here of how you can contribute to that. But you could extend on that and contribute to it via the terminal, as we covered, if you wanted to practice that and rehearse on there. So that's it. That's everything GitHub that I felt I could cover without making this absurdly long video. I really want to keep helping those. So if you have questions, you know, this might have got you started and there's something I neglected to mention or I didn't cover quite how you needed it to, bring it to Twitter. I would love to help. Feel free to tag me and just tweet at me and, you know, let's keep going. I really want to help the next wave of people get into GitHub. My own projects that I have there's 200 something of them. They're quite friendly. If you want to experiment with README requests, as long as they're providing some value and you're not just putting a dot if you're fixing the spelling errors or what have you, go for it. I would love to interact and help you to feel comfortable on the platform, and that can be a good way to do it. So all of that said, I hope you enjoyed GitHub and I'll see you at the next one.